Welcome back. For those who are still watching, we are going to look at how we can write partial fraction decompositions of improper algebraic fractions. Let's start with the example. Express this algebraic fraction as partial fractions. Now, this is an improper fraction. If you remember from the first video, this fraction is top-heavy, meaning the degree of the numerator expression is bigger than the degree of the denominator expression. If you expand this, it's going to be something like x squared and so on. And we have x cubed here. The degree of 3x cubed is 3 because of the power, and the degree of this expansion here will be 2 because of the power. So what are we going to do? We have seen in the first video that if we do long division, we end up with a quotient of the form ax plus b. So we have to start our partial fraction decomposition with this quotient. And then we go on with the remainders being c over x minus 1 plus d over x minus 2. Now at this point, I can tell you that a is 3 by just looking at the given algebraic fraction. And you don't need to do long division to figure out that it's 3. Well, after all, this is 3x cubed over x squared something. So if you do the division, if you simplify, you end up with 3x, right? So ax must be actually 3x, therefore a must be 3. So instead of writing the partial fraction decomposition starting with ax, you can write 3x directly. So you will have one less coefficient to calculate. Hence, actually, the coefficient names themselves can be a, starting from here, and then this will be b, and the last one, instead of writing d, it's going to be c. Now, this is my partial fraction decomposition, and now it's time to find the constants. So let's do equating the denominators bit. So this is going to be x minus 1 times x minus 2, and it's going to be the same for both this and this. And this is going to be x minus 2, and this is going to be x minus 1 only. So 3x cubed, now I got rid of the denominators, is 3x times x minus 1 times x minus 2 plus a times x minus 1 times x minus 2 plus b times x minus 2 plus c times x minus 1. And if I start substituting the roots, so I say for x equals 1, which is the root of the first factor, the left-hand side will be 3, and the right-hand side will only have this term because every other term has x minus 1, so they will just cancel out. So I will only have minus b here because 1 minus 2 is minus 1 times b minus b. Hence, I should have b to be negative 3. Now, for x equals 2, this is the root of this factor, I will have the left-hand side to be 24 equals, as you can see, the first 3 terms have x minus 2 as factor, so they will cancel out to 0. And I'm going to be finding c, this one. So if I substitute 2 minus 1 is 1, 1 times c is c. Apparently, c is 24. Now, I have to find a. Now that 0 is not any roots, I can go like x equals 0, and the left-hand side will be 0. And when we substitute 0 to the right-hand side, because of this factor, the first term will be 0. The second factor will be minus 1 times minus 2, which is 2, a. And we know b is minus 3, and 0 minus 2 is minus 2. Minus 2 times minus 3 is 6. And the third term, c is 24. 0 minus 1 is minus 1, so it's going to be minus 24. Hence, 2a must be 18. From here I can say a is 9. Now the question is, express this fraction as partial fraction, so I have to write hence it is equal to 3x plus 9 plus, well, b is minus 3, so it's going to be minus 3 over x minus 1, and c is positive, so I can write plus 24 over x minus 2. So this is the partial fraction decomposition of this algebraic fraction. And here is the second way, which is simultaneous equations way of solving this question. In the next few examples, I will only write the partial fraction decomposition of the given algebraic fractions, because the solution is somewhat the same in terms of method. For example, if we have 2x over x plus 1, well, this is not a top-heavy fraction. The degree of 2x is 1 because the power of x is 1, and the degree of x plus 1 is also 1 because the power of x is 1. However, just because this is 2x over x plus 1, if you ignore 1 and write 2x over x, you find 2. So you should be starting with this and go on with a over x plus 1. So this is how you initially write your partial fraction decomposition. Or if you have something like x squared minus 5x plus 7 over 2x minus 1 times x plus 1, then, well, this is again not a top-heavy fraction because the degree of the numerator is 2. You can see that this is 2 here as the index. And 2x minus 1 times x plus 1 will give you 2x squared and something. So the degree of the denominator is also 2. So in that case, you will again disregard whatever writes here and the rest of this and consider x squared over 2x squared, which simplifies to 1 over 2. Hence, you have to start with 1 over 2 plus a over 2x minus 1 plus b over x plus 1. You don't need to show work to end up with this constant. You can directly start writing the partial fraction decomposition. Or, if you have something like this, then you're going to check the degrees again. You can see that the numerator is degree 3 because of this power here, and the degree of the denominator is 2 because if you expand it, you're going to end up with 2x squared and something. So if you consider 4x cubed over 2x squared only, you will end up with 2x. So you can start your partial fraction decomposition as 2x plus a plus b over 2x plus 3 plus c over x minus 5. Now, a note here, we don't know if a exists. The chances are it may be a non-zero value after your calculations, or maybe you're going to find it 0. But just because we have to consider all possibilities, we just write a constant there. But if you end up with any of these constants being 0, well, be alert. You may check your work again, but this is not impossible. That's what I'm trying to say. Another example. This algebraic fraction has two expressions, both of which are of degree 3. You can see the power here is 3, and if you expand it, there are 3 factors here. So if you multiply x by itself 3 times, you're going to end up with x cubed. So basically, what I'm looking at is 3x cubed something over x cubed something. So I'm going to end up with 3 as a constant. So this is how I have to start writing my partial fraction decomposition. It's going to be 3 plus a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared, because there's a repeated factor here. Now, I don't expect to see something like this algebraic fraction. However, if I consider the first terms, like 5x cubed over x, I will end up with 5x squared. So my partial fraction decomposition must start with 5x squared plus ax plus b plus, well, c over x minus 7. However, I don't think that we are going to end up with a quadratic here as a part of the partial fraction decomposition. But just in case, let's include this here as well. So this is what the curriculum covers about partial fraction decomposition. However, in the next video, I'm going to show what we're supposed to do if we have an expression which cannot be factored in the denominator. Thanks for watching.